but all right, let's go. Okay, wait, I need to press some button. Okay, welcome back. So we have a. do I dare to call this an inequality? We have a 6-variable inequality, all right? But there's 3 equations, and I've been told by my sources that you want like the smallest possible value over like all hextuples. So the answer is not in terms of any of the variables. It's an absolute constant. And so I mean, bz plus cy. I should just solve for x, y, z in terms of ABC, right? Because if I what's the coefficients of x? B plus c, b, yeah, b plus c, a, c, c. They will be less than 0. Oh. That's true. Some of them might be negative. I guess, like, how bad is it? No, I don't think you want to solve for ABC. Well, actually, no. Solve for ABC doesn't make sense because it literally. Actually, no, it does make sense. I don't know. I feel like I should just solve, and then see if it's negative. Right? Unfortunately, that requires me to solve a system of 3 equations in 3 variables, but we'll have a bit of faith. All right. So I'm gonna. Okay, let's just solve. I don't think this will be so bad that I'm like I regret it, because it's like, what else are you gonna do? The other possibility is that you do like some sort of like Cauchy type thing on the, but I don't know. But it's like you need to get something that's independent of ABC anyways, or like you'll. If I was going to try to like cheese the bottom with Cauchy, what do I do? Just yeah, okay, let's just solve it. Screw it. I don't see a reason not to solve. So, oh shit. There's going to be cases based on whether A and B and C are equal, aren't there? Oh lord. Okay, let's. No, actually, maybe not. Okay, C A minus B. So okay, C A y minus bx equals a squared minus b squared, which is good enough. And we also know that AY plus BX. Okay, so this is not bad, right? I mean, it is what it is. You can't. It's equivalent to the problem, so it's like, you know, what are you gonna do? Okay, very good. And then so x is given by. Well, let's do y because that means I just add, right? 2ay is equal to a squared minus b squared over c plus, so a squared minus b squared plus c squared over c. To AC. Okay, and as expected, this is like cyclic in the right way. So if you do the same thing, boom, boom. So ABC you can think of as the sides of an acute triangle is the condition for them to be positive. Okay, see, we're fine. We're fine. Everything's okay. Yeah, everything's okay. Yeah. Moving on. Okay, and then what's the actual inequality that I want to prove? So we want to minimize some blob over ABC is the size of an acute triangle. We could choose something. I think we can do. Am I going in a circle? Hang on. It's like if I pick X, Y, and Z, how likely do I expect there to be ABC that satisfy it? I don't, because the ABC are homogeneous, the XYZ are not. So for almost all triples XYZ, there's no ABC. Thank you, Dotted, for the sub. It's been 19 months. Okay, so let's just write out what it is. Okay, so minus a squared plus b squared plus c squared all squared here, and then 2bc, and then okay, so fix XYZ. Well, okay. This is a geo problem, isn't it? Oh god damn it, it's geo. Thank you, Bart. Yeah, I definitely recognize that identity. X squared plus y squared plus c squared plus 2xyc equals 3. Yeah. Oh, I don't know how to interpret it. Acute triangle. So y equals. So like x is going to literally be it's cosine, right? Is what it is. Cyclic sum of cosine cosine squared a over 1 plus cos a, and then we do the oh come on. Anyone know if that's like a thing? Yeah, okay, there's sides of a acute triangle and then by the law of cosines, it's literally, okay, well, great. Cosine of 60 degrees is 1/2. But like, okay, like at that point, can I just like cheese it? Or something like, I feel like this is not, this can't be that sharp, right? So okay, if you do the naive Kochi, this is like, so cosine squared a is 3 plus 3s, and we also know what the answer should be. We think that xyz are minimized. We think it should be when the cosines are all equal, i.e. it's equilateral, cosines are 1/2. So our goal is to show that this is greater than or equal to whatever this equals at 1/2, which is 1/4 over 3/2 is a 6, 1/2, right? So I'm letting S be the sum, just like straight sum of the cosines, which we think is like 3/2. Wait, did I screw this up? Hang on. 1/4 over 3/2. Okay, so so what does it come down to? So i.e. we would like s squared to be greater than or equal to 3 plus 3s, which factors, because of course it does, which is 2s minus 3 times s plus 1 is greater than or equal to 0. And does it go the right way? So like there's a sense in like if I get lucky I'm just done. 3 plus s? Fuck, yes, sorry, you're correct. 3 plus s. Yeah, that was why I was almost working out. Yeah, okay, cool. So then the question is like, is the sum of cosines in a triangle at least 3 halves? Because if so, we're fine. Cosine is... Yeah, I mean, cosine is... shit. But it's acute. Okay, so we're fine, because you can use Jensen. Alright, we're done. Alright, cool, cool, cool. Yeah, Jensen is fine. Jensen is fine. I forgot for a moment that we were acute, and I was like, oh shit, what if it's obtuse? But like, no, they're just all non-negative, and it's okay. Yeah. Cool. Alright. Did they tell me what the problem number is? No? Okay, whatever, that's fine. Is convex... I have no idea. I actually don't even have a guess whether it is or not. I was just looking at it, I was like, this doesn't look like it should be very precise, because the expressions are pretty, like, small, so I'm going to just run it over. I agree that's the next thing I would have tried if this didn't... Actually, maybe I wouldn't have tried that. It's still pretty ugly. Okay, I'm gonna keep this calculation down here. Yeah. Honestly, I should have gone tipped off just from the expressions XYZ being like this, literally what they are. But when Bart gave me the thing like x squared plus y squared plus z squared plus 2xy equals 3, I was like, oh, that condition. I've seen that before. And then it clicked. Answer, we agreed the answer was 1/2, right? Achieved at, man. Yeah, so it's kind of funny because like the x squared 1 over x thing doesn't really depend on x, y, and z. Like it's kind of like there's two slightly unrelated problems being stitched together here. Can't you use geometric interpretation? What geometric interpretation? Do you have a geometric interpretation for cosine over 1 plus cos? I thought about it for like 3 seconds and I was like, I don't want to deal with this. What's the least number of words? Oh man, I gotta show you this problem. Prove that. 2 words. And the form's actually not very easy. By which I mean it's a Bulgaria 3, so it's not easy. And it took me freaking forever on stream. We actually did that one on stream. Yeah, you can use is if you want a shorter, I guess. Yeah, like I wonder if they could have just literally written x plus y plus z here, and it would be a little different. It's just kind of like, well, the exact shape of the expression ended up just not mattering because we pinned it down to the sum of x plus y plus z anyways. Z formal x that vanishes. Oh, I think I remember that problem. Actually, yeah, that was on a Brazil Revenge in some year. It was funny. I liked it. I think this still counts as algebra. Kochi, trig, manip. Oh wait. Oh, I'm sorry. I put the wrong source. It showed up in China first. China 2005 second round. Can I verify that claim? Yeah, okay. I should use the first source then. Well, I don't know how to find it in the index. You know what, we'll use this URL and just change the source in the system. China 2005. Do I already have a problem called China 2005? No. But anyways, I'll post a solution. Ah, fuck. Come on, come on, come on, come on. There we go. Oh, someone found it. I just posted.